Okay, let's finish up our last two on 8.4, problem 6 and 7. Okay, but you'll notice at the top it's area as an accumulation process revisited. Okay, so we have a graph. The graph of the function of g consists of a quarter circle and 3 line segments shown at the right. Let f be the function defined by f of x is the integral from -1 to x of g of t dt. Do notice they described this graph as g, yes? So I always like to pause and think that, okay, this is g. Now, with that in mind, they ask us to find f of -5. Now, if we're finding f of -5, plugging -5 into x, right? So if we plug it in as is, it's the integral from -1 to -5. Excuse me. And we're going to say of g of t dt. Okay, and that just refers to the graph there. Now, I think, first thing, I think Tate already said it. Okay, we need this order to be lower limit to upper limit. So we're going to flip, which means we're going to do the negative of the integral from -5 to -1 g of t dt. Okay, and this is what we're going to be doing for f of -5. Now, the integral from -5 to -1. We need to do what at this point? We need to look at the graph, okay, because it's the integral of g, okay, g of t dt. That t is just like our dummy variable, so to speak. Okay, so it doesn't get confused with x, but we're integrating from -5 to -1. We're looking at a graph, so that means we're finding all of the areas. Okay, so I'm going to put a bracket or parenthesis to get started because I'm going to have a negative out front. Okay, -5 to -1. What do you see first? Quarter circle. So that's going to be what? 1/4 pi r squared, so 2 squared. Okay, so we definitely see the quarter circle there.
The next two will just cancel out.
Okay. So officially, okay, I see what you're saying. So right here and right there are going to cancel each other out because one's above, one's below. Okay. Officially, though, it'd be what? It'd be 1/2 times a base of 1 and a height of 2. That's the triangle above. And then we're going to go to the triangle below. So it's going to be minus 1/2 times the 1 times the 2. Okay. Totally agree, though. We're going to have some canceling action. So if those two triangles cancel out, we just have the quarter circle. What do we know about the quarter circle? It's just going to be pi. And we have the negative out front, so this is -pi. So f of -5 equals -pi. Okay? Let's talk about b then. Find the values of x on the open interval, -5 to 4, so the whole graph, where f is decreasing, and justify your answer. What'd you say? Okay, and that's the question we've got to figure out is what graph are we looking at here, right? So let's see, where do I want to put B? I don't need as much room for B. I'm going to put B down here, I think. I'm going to run out of room the way it is. I have plenty of room on my paper, but it just doesn't correlate the same here. But they're asking about F, right? Well, what connection do we know here? If you go back to this statement right here, yes? Well, F is the integral of G, or what happens if we take the derivative of both sides? The derivative of F is going to end up equaling G. Is that a fair statement there? So we know that F of X is equal to, F prime of X is equal to just regular G of X. Okay, so when I say that this is the graph of G, it is also the graph of F prime. So this is a derivative graph. So when is a function decreasing? What?
Below the x.
When what is below the x-axis? When the derivative is below the x-axis, because so a function is decreasing when the derivative is negative. Okay, right? Because you remember when we'd find a negative derivative, that would tell us the original graph was decreasing. We find a positive derivative, that tells us the original graph was increasing. Does this sound familiar from first semester? I know it's been a minute, but that's what we're looking at here. So with that in mind, -2 to 1. Because from -2 to 1, that's where the graph is negative. And so that's where my derivative is negative. So I'm going to write here is that f prime of x is less than 0, or in other words, negative, on the interval -2 less than x less than 1. So since it's negative on that interval, it's decreasing on the interval. So I'm going to say f is decreasing on -2 less than x less than 1. Excuse me. Okay, you ready for C? Write an equation for the line tangent to the graph of f at x equals -1. So what do we need to write an equation of a line? We need two things to write the equation of a line. A point and a slope, yes? Okay, just, going back to general algebra here. You need a point and a slope. Okay. So what do we know right now? We know x equals -1. So we have half a point and no slope. So what are thoughts here? Slope is the same as doing the what at that point? Derivative, yes? Remember the derivative is the slope of the tangent line? Okay, so we need to technically find the derivative at -1 of f, yes? Now, what did we state in our last part that f prime is the same as?
G.
So what we really need then is g of -1. And what do we have up top? We have a g graph. So what is g of -1?
-2.
G of -1 is equal to -2. Now, what was this that I was just finding?
Point.
No, this was f prime. So this is your derivative, which is your slope. Okay. So we know the slope is -2. We also need a point. And again, we're doing this for the graph of f, yes? So if we know -1, what do we need to find? We need to find the y value, which means we need to find f of -1. Well, do we have a definition for f up above? We had an equation for f, didn't we? So f of -1, according to our definition, is the integral from -1 to -1 of g of t dt. What do we know about an integral from -1 to -1? When your bounds are the same, it's always equal to 0. And just think about logically. If you had something to actually integrate and you plugged -1 in, minus, and then you plug -1 in again, logically it says 0 now, right? Okay, so our slope is -2. What's our point then? -1, 0 is our point. And it asks us to write an equation for the line tangent to the graph. I tend to go point slope. So y minus the y coordinate equals m times x minus the x coordinate. I tend to go point slope. Remember, y minus y1 equals m times x minus x1, which if you drop off the 0, it's just y equals -2 times x plus 1. Okay. This is really just tying a lot of old and new together in this problem. It really is. Okay, D. Find the minimum value of f on the closed interval -5 to 4 and justify your answer.
Plug in your zeros and inputs.
What'd you say? Plug in?
Zeros and inputs.
Yes, to an extent. Technically, I don't have to plug in all of the zeros.
Okay.
And we can talk, you know.
Right.
Okay, so first of all, they give us an interval, yes? So do we have to consider those endpoints as possible minimums? Right? Okay, so when we think, I'm going to say x, this is going to be f of x, right? So the endpoints of -5 and 4, we're going to have those values, right? And then, okay, what zeros did we have? We have zeros of -2 and 1, yes? Now, we can eliminate one of those that we don't even need to test because it's asking us to find the minimum value. When do minimum values happen? When your graph is changing from decreasing to increasing. So I need to consider places where my graph is changing from decreasing to increasing, but do I need to consider places where my graph would be changing from increasing to decreasing? No, increasing to decreasing would be a max, yes? Okay, so increasing to decreasing, keep in mind this is an f prime graph, right? So -2 or 1, which one am I using here? What? 1. Because 1 is going from a negative, so a negative derivative means a decreasing graph, to a positive, And positive derivative means increasing graph. Does that make sense? Because we're looking for minimums. And so think about it this way, guys. You remember when we did these lines? Okay. From -5 to -2, my graph is positive. From -2 to 1, my graph is negative. From 1 to 4, my graph is positive. So that means that was my derivative, right? So that means my original graph is increasing, decreasing, increasing. Right. So we want to use 1.
Okay.
But -2 would be a possible max, so we don't need to use -2.
I thought you said eliminate 1, and I was confused.
Okay.
I was thinking eliminate -2, and I thought you said eliminate -1.
And I think in his defense, I think I might have changed the question I asked in the middle of the process there too. So that might be partially on me. I saw confused looks. Are we better now?
Yeah.
Okay. So now, do we know any of these? We know f of -5.
Yes, -5.
It is -pi. I don't think we know f of 1 or f of 4, do we? We use f of negative. We know f of -1, but not past that. Okay. So f of 1, and trying to think. Let's see. We already know this is pi, right? We know these pieces were 1 and essentially -1, which we know they canceled out. What about this next little triangle here? That's equivalent to -2. And while we're doing triangles, what about the triangle from 1 to 4?
1.5.
Okay, 1.5. I'll take it. Okay, so there's the catch. Okay. Sorry, I was really confused with my own answer. So in order to do f of 1, here's what I forgot, if I'm being honest. What's my integral here? You start at -1. Maybe you guys didn't forget that, but I did. So when we do this, for 1, it's f of 1 is the integral from -1 to 1. What's -1 to 1 going to be?
It's going to be 2.
-2?
-2.
Right?
Yeah.
Sorry, I was going all the way back to -5, and I had pi in my answer, and then I'm looking here, and there's no pi in my notes, and I'm like, can't be that confusing. Okay, we've also got to find f of 4, which means the integral from -1 to 4.
-0.5 or -1/2.
-1/2, -0.5. Okay. With that in mind, find the minimum value of f on the interval. -pi is our minimum. Okay. Now, when they say find the minimum value, realize they are looking for a y value. I've talked about that before, and I'm going to keep throwing that at you. If they say, where is the minimum value located, then they want x. But the minimum value itself is the y value. Okay, so, and then it said justify, right?
Yeah.
Well, because, I mean, our proof is there. We did what she often calls the candidates test. Because we, and I guess what else do I have in my notes? The minimum occurs at endpoints or where f prime equals g changes from negative to positive. The minimum value occurs at x equals -5 and is -pi, and by the candidates test. I don't have room to write all that, but I will say minimums occur, I am going to throw this in here so we have it in writing. They occur at endpoints or where, I'm going to just say f prime of x because it's really just the derivative that matters here, changes from negative to positive. Now, in all reality, would it have been the end of the world if we would have tested -2? No, we would have gotten the max, or a possible max. Okay, we wouldn't have got, Okay. So there's that. Min value for us occurs at x equals -5 and is -pi. And that is by the candidates test. Okay. And again, I know it's writing a lot there, but I'm just trying to get you guys, thinking through all the information. Okay. Yeah, we definitely wouldn't have gotten through that yesterday. I could have just said, and we'll skip it. But on the flip side, there's a lot of good review in there. I don't know, in all honesty, how much that's going to apply to your homework. But it's a lot of good review. So, okay, let's look at example 7. The density of cars on 10 miles of the highway approaching Disney World is approximated by f of x equals 180 times 4 minus natural log of 2x plus 3, where x is the distance in miles from the Magic Kingdom entrance. Find the total number of cars on this 10-mile stretch. Any thoughts of what we're going to do? Keep in mind, we do have our friend, the calculator symbol over here.
The answer from 1 to 10?
Almost.
0 to 10.
0 to 10, because we're not going to end 1 mile from the entrance. We're going to end at the entrance. Yep. That is it. The integral from 0 to 10. You could write, so here's the deal. You could write this one because f of x is defined in this problem. You don't ever have to write that equation. Okay, because f of x, now you don't get to just magically create something, but you could just write that, put it in your calculator, and you're good to go. Okay, now if you want to write the equation instead, could you? Yes, you could write the integral of 0 to 10, 180 times 4 minus natural log of 2x plus 3 dx. You could have done that also. Either way, it's the same answer. And officially, what is that? 2,806 and 1,152 thousandths cars. Officially, I'm leaving it as 3 decimal places because it is a, it is AP. Although unofficially, we are talking about cars, and so, you might consider a whole number answer. Okay, guys. You have some work time. As you go to do these homework problems, okay, notice they say sketch the region bounded by the graphs of the equations and find its area. Sketching the graph, okay? On those, do what you can without the graph of the calculator. I'm not saying all of them you can graph without the calculator easily. But like, for instance, number 1, y equals x squared. You can graph that. Okay, y equals 4x. You can graph that. Now the deal is, can you figure out where those intersect without the calculator? With a little work you could.
Like lowering the point.
Okay, but that's, that's something to consider. Now, some of them are going to be easier to do without a calculator than others. Now, I will say, like, number 8, 9, and 10 specifically say calculators. They're not going to expect you to try and graph those without a calculator.
Oh.
The others, they want you to try. Okay? See what you can do with them.